Welcome to Revolution Against Evolution. I'm your host, Doug Sharp.
My co-host Rich Gear with you, and Doug, we're going to reprise some information that we got from a very well-known creationist, Don DeYoung, and he's got a thing we said, Discovery of Design. Is that the title of our show tonight?
That's the title of our show tonight.
Okay, Don DeYoung's a very special guy, really very approachable. I'm really amazed, Doug, at one of the things that the luminaries, if you will, in the creation movement, that they're very accessible, approachable, and usually, pretty much want to share with you the stuff that they know, and they're really approachable, I should say. And Don is no exception. He was really good. When we were up there earlier, we had
this was at the conference center at Higgins Lake.
Right, Ram Center. What was the date of that? When we were
it was over Memorial Day.
Memorial Day, that's right. Yeah, Memorial Day this year, 2013. We were up there, and he was there. He was really the premier keynote speaker, I guess, but if you want to call it there, and had some really interesting things to talk about design, and
And basically what he was trying to show is that many of the different products that we use daily have their origins in designs in nature. And what he was showing was that these different things, such as burdocks, with the burrs, he was telling about how the fellow who discovered that and looked at the burrs under the microscope, why do they catch on your clothing? And they developed Velcro from this.
Velcro's one. A lot of people are familiar with that one. It's an amazing discovery. Yeah, and it's
a little bit about Don DeYoung. He is a professor at Grace College in Winona Lake, Indiana. Mm-hmm. And he is also the president of the Creation Research Society. The Creation Research Society is the oldest creation society in the world, I believe.
Yeah, when did they start? When did they form?
1963.
63, okay.
It was right after Dr. Henry M. Morris's book and Whitcomb's book, The Genesis Flood, came out.
Yeah, that came out in 61, I think.
Yeah.
So 2 years after that they formed. Okay, all right.
And so I know there's some creationist organizations in England, I think like the evolution protest movement that's been around for a while.
Okay.
But this one is the first one in America that, and it's been around the longest, and it's probably one of the more respected creationist organizations.
Well, they do original research. I think that's what's really amazing about, a lot of the organizations, they do great work, and they basically reprint or glom onto discoveries, usually done in the secular world, and show how they reveal a creation viewpoint, or they let some of them create museums. But creation, CRS, to my knowledge, is one of the few that really focuses primarily on original research. I think ICR does some original research as well. They have a school and things like that. But CRS really, that's what they do. And they come up with a lot of neat stuff over the years. I still remember some of when we were out in Arizona and looking at their place. It's very real. I don't say it's that impressive of a place. It's just what they're doing is very impressive.
Yeah, what it is, what Rich is talking about is the Van Andel Creation Research Center out in near Chino Valley, Arizona, and they actually have some laboratory equipment like a electron microscope and a lot of other things that they can use for research. I remember one piece of research they were doing was they had a FM radio that was tuned to a distant radio station. Okay. And they were using this as a mechanism to track meteorites.
Oh, really? I don't remember this. See, you would remember this because you've always been fascinated with radios as long as I've known you.
And what happened was that when the meteorite could come in, all of a sudden that distant radio station get reflected off the meteorite, and you'd hear it briefly. So go chung on and then back off again. Okay. And so they were using this and recording the sound as a mechanism to track the frequency of meteors coming into the atmosphere.
Interesting. I don't remember that one at all, but anyway.
But that's an example of some of the different things that the creation research people have done. And, you know, there's just a whole bunch of different books that DeYoung has written. He also has written quite a number of them on astronomy.
Say that's what he's really known for, I think, in the creationist thing is that, and we're not going to talk a lot about that tonight. We're going to talk about more about his design principles of design things.
Well, we're going to let him speak for himself.
Well, that's true. Yeah, he'll speak for himself.
Well, now we're going to talk about design for a little while, and let me just do something else here for a minute. We're surrounded by design, and maybe time for just a little math lesson. Math on a Saturday. So let me write some numbers here. Let's see. I'm just starting kind of a sequence of numbers. I got a 1 and a 1 and a 2, and a 3, and a 5. And what comes next? 8. I heard it. 8. Number 8 comes next. Okay. What comes next? 13. What are we doing here? Yes, you take the two previous numbers and add them together to get the next highest number. This is a famous sequence of numbers. It's called a Fibonacci series. Have you heard of Leonardo Fibonacci? You say, I don't need this on a Saturday morning. This guy lived about 700 years ago, and he would have liked this setting. I mean, he was into nature, but he was also a mathematician. And he got to realizing that there's something special about this sequence. These numbers appear in nature more than they should otherwise. There are a lot of flowers that have 5 petals or 8 petals. There's not very many that have 7 petals. There are some, but those are kind of exceptions. Well, there are 3-leaf clovers. Now, there are 4-leaf clovers, but those are mutations. Those are mistakes. You know, clover come with 3 petals. And so these numbers are just out there in nature, and some of the larger numbers as well, especially if you start to count the spirals on a pineapple or a pine cone or a sunflower. The bigger numbers are there. On our break here, I walked outside, and there's some white pine trees, and I was just grabbing some of the little needle connections. Let me just pass this around. You can see how many needles there are on a white pine tree. There's always 5. It's a Fibonacci number. Now there's some red pines, I think, that have 3 needles, but it'll always be one or the other. I would challenge you this weekend to look for these numbers in nature. Even the animal world, like a sand dollar has a 5-pointed star on the back. Anyway, biologists have never known what to do with this, why these numbers seem to dominate in nature. Again, especially the bigger numbers. You know what I think we're looking at here? God's fingerprint. Maybe we don't like math, but he does, and math is the language of creation, and he's embedded these numbers. And notice this is a rather intelligent pattern here where you're adding them together to get these numbers. And again, there are exceptions, but they're out there. Look for them this weekend, especially in the plant and the animal world.
Now, isn't the filiary seed a logarithmic spiral? Is that...
A logarithm has Fibonacci numbers embedded in it. And when you talk about a spiral, that's seeds, that's shells, that's galaxies. This thing is just everywhere. More preliminaries here. I'm kind of representing this weekend the Creation Research Society. Remember this, the oldest creation group? All the others have sprung off from it. And you want to sign up here. Right? We have a free newsletter. It's kind of a fundraiser, but we tell you what's going on in meetings and new books and things like that. So no charge to sign in. And I'd like to collect some names. I don't know if we mail stuff with you forever, but if you'd like to hear more about the CRS. And back here on that book table, it looks like all the free stuff has kind of gone away. But where we have those books, and they're all bargains, you know, there's a set of DVDs that look like this. And I just wanted to mention, I put this together a year ago with our local child evangelism group. We got a group of kids together, homeschoolers, and we started a discovery club. And there's 5 little lessons on this where the kids are there and they're doing hands-on experiments for the kind of things I like to do. So if you're working with a good news club, backyard club, Awana or whatever, it might be some material you'd like to use here. There's 5 distinct lessons, and the kids are doing things, and it always wraps up with a good gospel presentation on the end. So anyway, that's what our local child evangelism group's been working on. Fun stuff. Are we back to this talk here now? Discovery of design. Let's see here. This topic kind of gets close to this whole thing called intelligent design. And I know this kind of gets smacked often by creationists because, you know, it's no good by itself because it's not talking about who the creator is. But this certainly has its place, like those Fibonacci numbers. It is part of the whole story here, this worldview, you know, our set of beliefs. So it's one part of it, but I don't want to, you know, cancel it out. It has its fair share, so that's kind of what we're looking at for a little while here in this talk. Yeah, not isolated by itself, but an important part of the whole big picture. Well, my view is that when God put this world together, He embedded out there all kinds of useful ideas. Things just waiting for us to discover and apply, to solve problems, to come up with new products. I mean, that's what planning is all about. And this is today where inventors and engineers are looking at out of doors to come up with new products. Now, they'll say that these things have slowly evolved over, you know, untold ages of time. Nuts to that. They've been here since the beginning, since the creation. But there are all these ideas. And so we're just going to look at a few of them this morning, where they've looked at something in nature and then come up with a useful product, some kind of design. It all shows God's glory and how He put it together. And I got a bunch of them. I don't think I have 100 of them, maybe more like 15 or so. And we'll see how the time goes. And by the way, what kind of impels me in this area is this verse from Job. Speak to the earth and it'll teach you. To me that says that if you honor the Lord and look carefully, whether you're working on learning a language or working in the outdoors, God can reveal things to you. And I think He reveals how nature works and how we can make good use of it. So anyway, that's kind of a verse that's behind this little presentation. By the way, pretty soon you need to do something with me. You'll each need a sheet of this green paper. It got wet. But that doesn't matter. We're going to use it up anyway. So you can take one of these pages when it comes by, and we'll get to it pretty quick. Hey, let's launch into this stuff. Let me mention some interesting examples from nature. Have you heard of diatoms? Yeah. No, you can hardly see them. They're about 10 times smaller than the thickness of a human hair. But we're surrounded by them. They live in the soil. They're in the water, the fresh water, the salt water. They're everywhere. Whether they're a plant or an animal, they argue about that. But they're just little small-scale life. And these things live in these glass houses. They make out of silicon. This is what they look like if you look at them close. And there's thousands of different varieties. And again, they're everywhere. There's whole quarries full of these things. And so here's a picture. It looks like electron microscope of diatoms. Now, some of these are really interesting when you look at them close. Again, this is silicate, this cage that they've made, smaller than a human hair. In the old days, they used to have contests to see how many they could mount on one slide. Don't sneeze while you're doing this. But there's these classic pictures, I don't know, with tweezers or whatever, when they would put those things together. Well, now, these things have been around since creation, and they're just, you know, there, and you can hardly see them. What good can they be? Well, during our own day, our era, there's this whole thing called nanotechnology. You've heard that word? Mm-hmm. This is making things that are so small you can't see them. Mechanical things, motors, and pumps, and generators. They're making these things dust-sized now. Well, some of these diatoms, when you look at them close, they look like a strainer or a sieve. And they function for that. Some of these diatoms look like a gear. What they can do is take a diatom, now they're rather fragile since they're made out of silicon dioxide, but they can take these things and coat them with metal, makes them more permanent, and they can use these things for gears in nanotechnology machines. These are ready-made components for this technical world we live in. Never realized until our present day. I'm thinking, you know, the angels are watching all this stuff going on, and they're standing back and they're saying, they finally figured that one out. My God made diatoms, you know. And Most of the stuff we haven't found yet. But what an interesting area that is. And with all those different shapes and sizes this is coming on, you can't even imagine how small these pumps and valves and things they're making, but this is going into medicine now, where you can take these inside your body and even do surgery on a real small level remotely. This is kind of getting into futuristic stuff, but that's nanotechnology. So I just brought some of these examples of discovery of design in nature, and there's more. There's always more. Slime mold. What is this stuff? You might see it if you walk in the woods. If a tree is decaying, that's kind of where it shows up. Often these quite interesting colors. They kind of argue whether this stuff is a plant or an animal as well. It doesn't have a brain. It's just material that grows. Well, this stuff has a way of sending out tendrils to find where there's food supply, and that's kind of how it spreads. And these things can form quite quickly, like just overnight. Even if you have a mulch pile or in your garden, you might see these kind of things, maybe where you don't want them. We're learning from these things. This is some work that was done over in Japan. Let me tell you what they did. They've got this big sheet of plywood, 4x8. And on it, they kind of drew a map of parts of Japan, especially around Tokyo. Then, on this big piece of wood, it's just set flat, they put little bits of food, actually probably little bits of grain or some kind of mush, where different cities are in Japan. And then they put some of this slime mold where Tokyo was. And then they just turned out the lights and let this thing run for 24 hours. These things are on the march. They're looking for food. And they reach out tendrils. And when they can find food, they'll strengthen the line. Where they can't find food, they pull back. And this stuff grows. And this is actually the time scale. These are hours, 5 hours, 16 hours. After 26 hours, they turn the lights back on. They do real well in the dark, these things. And what they found out was that this slime mold had made connections to all these other little food supplies, which are cities in Japan. And they got to looking at this and realized that's just like the rail system that they have, where they are trying to minimize the distance between cities and where to lay down these tracks. In fact, in some cases, the slime mold did a better job. You have multiple things to connect. There's different, minimum ways to connect these things. And so they're thinking, we could use slime mold to help us plan transmission systems for towers and for highways. The next, maybe 20 years from now, when we're traveling on a highway, it will have been designed in that direction by slime mold.
Now, what I also wanted to do is to talk about his astronomy focus, because one thing I remember about his book about the moon, its origin and its significance, is that it talked about some of the unique properties of the moon, Earth, and Sun system that is, and it doesn't occur anywhere else in the
No, it's very special.
universe.
Yeah.
And that is that it's the only place in the known solar system, anyway, and in the universe, where a total solar eclipse or a lunar eclipse is possible, because the relative size of the Earth, Moon, and Sun in relationship with each other,
And the distances,
distances
from each
make
other.
it possible for the moon to totally cover the sun, and for the Earth to totally cover the, shield the moon from the sun.
Right.
And so between those, you can have total eclipses. Now, also, he talks a lot about the backside of the moon being a whole lot more heavily pockmarked with the
It
craters.
shields us from a lot of
Right.
meteorite damage from the Earth to the
And
Earth.
there's only one side of the moon that always faces. Now, some people call that, the other side of the moon, the dark side of the moon. Well, that isn't true. It's the part that's shielded from us, so we can't see it, but it's not dark because the moon rotates around the
Right.
Earth, but it's always has one side of the moon facing us, and that's fairly unique. Scientists really can't explain that, so it's a fairly strange.
Well, we would say from Genesis, God puts the sun, moon, and stars as for signs, seasons, to show us His handiwork, and the precision. Just the one fact you talked about, the relative distances from the moon to the earth, from the earth to the sun, and from the moon to the sun, all the things together that would allow the eclipses of both the moon and of the sun to be occurred on the earth. There's a precision there that it just seems it staggers the imagination that it could have just been coincidence.
Oh, this is getting confusing here. We're going off the deep end now. These galaxies, these whirlpools, these spirals of lots of stars. That looks like a little bit of gas, but really that's lots of stars. And we live in one of these things called the Milky Way. There's another one called Andromeda. There's one called Leo. There's even one that they have named Snickers. They've run out of names for these things.
Is that sister to the Milky Way, or was that what?
That was actually probably the whirlpool. This gets a little bit overwhelming, and you say, I don't even like to think about space because it gives me a headache. But anyway, if you're trying to keep track of it, I was just trying to think of a little way to, in our mind, I think it's good to know this part of creation. How about the letters MPG, like miles per gallon? Because this is the hierarchy of space. The M is the moon, our nearest neighbor. P would be the planets, our solar system, our neighborhood. And then the G part would be the galaxies. And there's lots of these things. They're spread out across space like islands, a galaxy, empty space, another galaxy, and that's the whole universe, physical universe. So a way to kind of keep, the list in mind. I don't know, does that help MPG? You say, I don't want to clutter up my brain with that stuff.
It's pretty interesting.
Let me go back to that, this one a minute here. This galaxy. This is a real problem for astronomers today as they look at these things, they take all these neat pictures. What we have found is when we measure the number of stars in these galaxies and what's in the middle, lots of stars, there doesn't seem to be enough material to hold it together because these things are turning. And it seems like they're going fast enough that they should disintegrate. They should be flying off in all directions, like a merry-go-round that's going too fast. But they don't, they're compact and they stay together. And so it's thought that there's something inside these galaxies holding them together that we can't see. And they call it dark matter, missing matter, dark energy. They have all these different names for it because they can't see it. There seems like there's something there holding these things and making them stable. I'm just giving you a real problem.
It's not a gravitational pull of sorts?
Well, that's what we know of it. It takes holding these things together, some kind of gravity, but we don't detect enough stuff in there to make the gravity to make it work. In fact, what they say now is that 90% of this galaxy is missing. Of every galaxy, 90% of the universe is missing. This is kind of embarrassing.
Where'd it go?
Wouldn't they like to know?
Yeah.
So they labeled it. They used to call it missing matter. Now it's got to be there, so it's dark matter. Now they've been looking for quite a while, and they can't find it. And they may yet find some exotic particles to kind of add to it. But this mystery in astronomy kind of makes you wonder after a while, and maybe turns your mind to Scripture. Over in the New Testament, book of Colossians, where it's talking about this stuff, a creation verse. And Christ is before all things, and by him all things consist or hold together.
Yeah, and if you think about the nonsense that has been propagated about creationists believing in a flat Earth, that story was actually made up by
Washington
Irving, and a few other atheists around the early 1800s that had an agenda to actually destroy the credibility of the Bible, and they made up the story that the reason that the Christians were the ones who believed in the flat Earth. Oh, that's not true, And back in the Greeks' times, Eratosthenes was one of the people who did the measurement of the circumference of the Earth. And that was really something that was known to all even in the medieval times, that the Earth was round. And in the Bible, in Job 26 verse 7, it says, it talks about the earth hangs upon nothing, and there was a circle of the earth.
That was in Isaiah. The Isaiah passage talks about the sphere. Actually, it could be translated sphere or the circle. You see,
Yeah, Isaiah
rounded-
40:22.
Yeah, 40:22. Yeah, and that's the circle of the earth, and they've known it for for a long time. But I think they conflate the notions of when the Roman Catholic Church was trying to get Galileo to recant from his geocentric to a heliocentric, from a heliocentric to a geocentric universe or solar system, and so they were conflating the flat Earth with that. There is a flat Earth society, so I think it's more tongue in cheek, though, isn't that right, Doug? I mean, I'm not sure it's serious. I think it's just tongue in cheek, but they do. People like to do that. They will put things together that have really nothing to do with one another.
The one thing that was really fun when we had him at the conference was he was showing how I think it's the leaf of the beech tree pops out of a pod and unfolds. And what he did was actually showed how that worked. It was he folded up a piece of paper, had us fold up a piece of paper and put it, and so it popped open like with the beech tree is.
There's a lot of stuff like that in nature. Well, we've talked about what the Fibonacci, the way it's calculated, 3, 4, 5.
Yeah.
I'm not even, because I'm not a mathematic guy, but it's a fascinating thing how in nature there's so much like seashells and things that open up in these spirals, and it's all mathematically calculated.
And the filiary seed is based on that particular mathematical formula, and this is the little plant that's has a spiral-like seed that screws itself in the ground.
Yeah.
It plants itself.
Yeah, we've done little hands-on little demonstrations of some of the seminars we've had. Take a little filiary seed, put a little water on it, and then it'll curl. Then it dries up, it'll curl back up, or what's
right. It curls back up. It stretches out when it's wet, and it curls back up when it dries. And by doing that, it plants itself in the ground.
Right, drills it like a corkscrew right into the ground. Yeah, a lot of cool stuff like that in nature, So,
well, I think we're going to end our show now. We'll see you next time on Revolution Against Evolution. We hope you enjoyed our time with Dr. Don DeYoung.